All right, Algebra 2 students, we are continuing our lesson in 6.2. So we're going to finish up 6.2 today. 2 learning targets for today. Let's jump right into your first learning target. I can use 2 points to find an exponential model. So finding our model given 2 data points. So let's go ahead and read through example 5 and we'll work through this problem together. So example 5 says, Tia knew that the number of emails she sent was growing exponentially. So it's increasing there, growing. She generated a record of the number of emails she sent each year since 2009. What is an exponential model that describes the data? So the first thing we need to do is determine our 2 data points. So what are our x and y values? So to do that, we're going to find x by calculating the number of years from the starting date. So x represents time in this problem. So x is the number of years from the starting date. So they tell us that the starting date is 2009. And then we're given 2 years. We have 2016 and 2015 there. So how many years have passed by the time it's 2016? Well, from 2009 to 2016, that would be 7 years. So x is 7 for our first data point. And then for 2015, that would be 6 years. So x is 6. So I could say that for my first coordinate, x is 7 at 1,400 emails, and x is 6 at 1,000 emails. Now be careful, don't use these dates. Don't say x is 2016 and x is 2015. You will get the wrong answer. It's not the year, but the amount of time for x. All right, now we're going to find y. So y is the amount of the quantity. So the quantity we're looking at in this particular problem is the emails. So number of emails here. So my y values are going to be the number of emails. So I can say that x equals 7 when y equals 1,400, and x equals 6 when y equals 1,000. All right, so now we have all the information we need. We have our 2 data points, our 2 points, we know the x and y's. So now we're ready to put this in our calculator. So the other day, we were working with this exponential regression in the calculator. So we're gonna use that again to come up with this model. So I'm gonna get my calculator out here. And I'm going to use these steps to find my model. Okay, so I'm going to go to Stat first, and then Edit. And then for my list 1, I'm going to enter in those x values. So for x values, we have 7 and 6. Oops, that's the wrong list. 7, 6. And then the y value will go in the list 2. So 7 corresponds to 1,400, and then 6 and 1,000. All right, so I got my 2 data points in there. Now I'm going to go to Stat, back to Stat, over to Calc, and then we're going to find the exponential regression. And then enter. All right, so there is your formula there. So your model is y equals a times b to the x, and then they give you your a value and your b value. So just plug those in for a and b. So y equals 132.8 times 1.4 to the x, and that is your model. All right, go ahead, pause the video, and you try one on your own. Do the try at 5. Let's see how you did there. So try at 5, a surveyor determined the value of an area of land over a period of several years since 1950. The land was worth $31,000 in 1954 and $35,000 in 1955. Use the data to determine an exponential model that describes the value of the land. So my starting date is the 1950. And then to find my x values, I'm going to calculate the amount of time passed from 1950. So in 1954, that would be 4 years passed. And then in 1955, that would be 5 years passed. So x is 4 when y is $31,000, and then x is 5 when y is $35,000. All right, then I'll just use my calculator to do the work. Stat, enter, clear that out. So I have 4 and 5. Stat, calc, exponential regression, enter. All right, then I'll just plug in those values and I'll get my equation. And there is my model. All right, so that does it for that learning target. Let's go ahead and go on to our second learning target. I can use regression to find an exponential model. So same idea, we're using the exponential regression. I'm still trying to find that model. So let's look at example 6. Let's work through this. Randy is making soup. The soup reaches the boiling point and then, as shown by the data, begins to cool off. Randy wants to serve the soup when it is about 80 degrees Fahrenheit or about 10 degrees above room temperature, which is 68 degrees. All right, part A says, explain why the temperature might follow an exponential decay curve as it approaches room temperature. So you're starting out at 212 degrees, which is pretty hot. And then over time, it's going to cool down until eventually it's going to reach room temperature, which is 68 degrees. It's never going to get colder than room temperature because that's not possible. So what happens over time is the temperature decreases until it gets closer and closer to 68 degrees Fahrenheit. So that shows a decay curve because it keeps getting closer to 68 degrees. That's your room temperature. So this is important because this tells me that my asymptote of this curve is at 68 degrees. So it's going to decay. So here's my XY. So let's say this is 68 degrees here. So it's going to get colder and colder and colder until it reaches 68 there. Okay. So let's go on to part B. It says, find an exponential model for the data. Use your model to determine when Randy should serve the soup. All right, so we're going to use our calculator to find our model. And we're going to use these steps below. So the steps are already typed out for you. There's a couple more steps that we'll add on in the end, but most of them are given to you. So the first thing we want to do is figure out our x's and y's. So it says enter the data as lists in the graphing calculator. So we're going to go to do that, just like what we did before. You're going to go to stat, enter, and then your x's will go in list 1 and your y's will go in list 2. But there's a couple things I want to point out to you for your x values. So x is time, and y is the quantity, which in this case is the temperature. But when you're putting in these values, notice how some of them have some seconds in there. So we have 0 minutes, 2 minutes, 3 minutes, 30 seconds, 5 minutes, 7 minutes, 30 seconds, and so on. So think about this in terms of minutes. 30 seconds would be half of a minute. So instead of putting in 30.3, I'm going to actually put in 3.5 or 3.3. Don't put that in, put 3.5, because 30 seconds is half of a minute. And then down here, same thing, 7.5, 7.5 minutes. So that takes care of your x's. This is going to go in list 1. And then list 2 are your y values. But now notice when we're sketching this curve here, your asymptote is at 68. Now your calculator works as a regression for data values that are approaching 0. So your calculator's thinking that we're approaching 0, but we're not. We're approaching 68. So what you're going to have to do is take your y's and subtract that 68. So minus 68, minus 68, minus 68, and so on. So when I put in my data values, it's going to look like this. Let me clear these out first. Okay, so 0, 2, 3.5, 5, 7.5, 10, 15, 20. Then I'm going to do 212 minus 68. 185 minus 68, and then keep going for all the values. Okay, my lists are set up, and then I'm going to find my model, just like what we did in the previous example. So stat, calc, exponential regression, enter, and there you have it. Okay. Okay, so once you have your model there, you're going to translate this function up vertically by 68 units. And the reason why you do that is because you have to account for all of this that we did. We subtracted, so to balance it out, we'll add that 68 there. So that is your model. So we found the model. That was the first part of the question. Find an exponential model for the data. Now we need to figure out when Randy should serve the soup. So when is this soup going to be 80 degrees? Because remember, he said he wanted to serve it when it was about 80 degrees. So to do that, we're going to enter our model that we just found into the calculator. So we're going to go to the y equals, and then enter our model, and then second graph. I already have it in there. Okay, good. Second graph. And then there's your table of values for that model. So if we want it to be 80 degrees Fahrenheit, that means that our y coordinate is 80. And then x would be the time at 80. Okay? So about 44, or it's actually closer at 45 here. So I'm going to say 45 minutes. About around 45 minutes, it's going to reach that 80. So here's your model. And then Randy should serve his soup at about 45 minutes. Okay, so that is how you use regression to find an exponential model.